we're starting fractions. There's only 3 weeks and a little bit left of this term. And fractions is a good topic. The warm-up for the ToDoodle 26 says, how many ways can we shade half of a 4x4 grid? And we're supposed to make copies. So if you look at this grid and click on it, you can make a copy, put it to the side. And obviously, if I used a nice wide thing, then I can say, like, here's just half of it on one side. I get half of the cake and somebody else gets the other half of the cake. But that's kind of boring. We can probably make some more interesting halves than that. So your job now to find more ways to shade half of that and make copies so you can have a place to write. Top half works. In gray, in black, it's the middle half. That's plenty of good shading. No one's grading us on artwork. On the right-hand side,
Bottom half.
so far all of these have had a block of 8 squares that are all touching each other. But we don't have to do that. Imagine like there's a pile of monkeys fighting over this stuff. Good, good. Okay. I will do one just to show you what I was trying to unsuccessfully to provoke you about. So I could say, I'm going to do like these two on the top row and these two, whoops, on the second row, like a checkerboard. So now I have half of them shaded, but none of the shaded ones are touching. So we could just like pick and choose which ones we want. So if you like tormenting your family members, I didn't check in yet about the 4 4s challenge from last week because, that's a good one with the 2 corners. But we can certainly say there's lots more ways to do this. And an interesting thing, which we don't need to do now, but makes good homework, is in the bottom. If we're only shading a quarter of it, so maybe we have there, there, and there. We're shading 4 out of the 16 boxes. Are there more ways to do that or fewer? If we're shading 8 of the 16, does that mean it's like a little too full and some of them start getting in each other's way? Or having 8, does that give us more options than if we only have 4? So you could experiment and see. If you were very thorough, how many ways can you shade half? If you were very thorough, how many ways could you shade a quarter? Okay, onward. Thank you for the warm-up. So this world has 3 kinds of fractions. The simplest are what we'll call kitchen fractions, and these are the ones that appear on your measuring cups. We use them all the time. Usually 1/6 is also included, and maybe 1/8. And if you do other things with fractions in real life, like carpentry or sewing, those are also the fractions you use. No one is ever going to say, I'm doing carpentry, I need to use 3/7, or I'm doing some sewing project, I need to use 5/12, or something like that. There's just only a few we really seem to use in real life for most things. Then the next group is called the unit fractions. And the unit fractions is any fraction whose numerator number is 1. So this includes something like 1/20th, which you probably aren't going to use in the kitchen, but it's a unit fraction because its top is 1. Everyone with me so far? And the ancient Egyptians only used unit fractions. And they're the simplest to use because no matter which operation you do, they all work pretty similarly. So there's one last group, all the other fractions, the ones whose tops are not 1, but those we're saving for Math C. We're not doing them in this class. We have to mention them just a little bit in the next few pages in ToDoodles, but we're trying to avoid them as much as we can. Ready to go on? Okay, here's a question for you. A picture of a classroom my son was in for 4th grade, I believe it was. There are between 20 and 30 students in this Ray's elementary school class. A quarter of them sit on bouncy balls. 1/4 of them sit on little cushions on the ground. And 1/3 sit on chairs. The rest get to be on the couch. All of the amounts are whole numbers, so we're not rounding. If you do 1/3 of the number of students, you get a whole number. If you do a quarter, if you do, it's just thirds and quarters. So find the total number of students and how many are in each ways. So you're going to have 4 answers, the bouncy balls. I guess yoga balls is what we call them too. Those little cushions that you can barely see. Chairs. And the others. And we know that these two are the same. They are both 1/4 of the total. How would we start this one? Okay, I'll give a hint then. So here is quarters. And here. Oops, no. Is thirds. So what numbers could we have for the number of students where the quarters and the thirds both work out? If we try 20, for example, that's not going to work, because if you try putting 20 in thirds, it doesn't come out even. You'd have 6, 6, and 6. 6 times 3 is 18. There's 2 left over. No good. So 20 can't be the answer. Which other numbers up here can we disqualify because they're not a multiple of 4 or they're not a multiple of 3?
Let's say 21.
21, yeah, 7 times 3 works. We could do 21 here, but it's not going to work with the quarters.
22.
22, that's only 2 times 11. It's going to fail both tests.
I'm gonna go and say 23 as well.
Yep, that's prime, so it's not going to work.
Anybody else want to go before I keep going?
I'm a little confused.
Ouch! What was that? Oh. Yeah, I'm a little confused too.
Oh, okay, thank you for letting me know. We're checking 24. If it is 24, can I split up the 24 students into quarters? Because it says a quarter of the students is a whole number that doesn't need to be rounded. So can I put 24 in 4 different boxes?
Yeah.
Yes.
Yeah, so 6 times 4 is 24. Can I also put 24 in 3 boxes? Because a third of them sit on chairs and that's not rounded.
Yeah.
8.
8.
Yeah.
Okay, so 24 works. So I'm going to put a smiley face by 24 instead of crossing it out. Does 25 work?
I would say no.
No.
It's not going to work in either of these. It would have to be 5 times 5. You can't split it up into quarters, and you can't split it up into thirds. Okay, 26.
No.
27.
Mm-mm.
27 would work for the 3s.
Yeah.
3, but it doesn't work for the 4s. 28.
No.
No. 29.
No.
30.
No.
No, so only 24 works. So what we had before has to be how we can break up 24. Okay, so a quarter of the students are sitting on balls, that's 6. A quarter of them are sitting on cushions, that's this 6 over here. The other 2 6s aren't there, they're doing something else. A third of them are sitting on chairs, that's this 8. So now I've used 6 and 6 and 8 over here. How many are left out of 20? 24.
4.
4. If I add up these, I get to 20. So there's 4 more to get to the 24. So here's our answer. It has to be that. This is a very different kind of math problem. We're not like plugging things into an equation and solving it. It's not like we have a bunch of fractions on the page to start with, and we're supposed to squish them together with plus and minus and things like that. So this is included, first of all, to help us think about fractions, to think about how these 6 students are a quarter of 24, because you could put 6 in every box. It's helping us try and waking up our brain to think about fractions being more than one fraction in the same situation. We have a quarter and we have a third in the same situation, and that's okay. And lastly, this is to show you the kind of question that the GED might have, even if it is one of these unit fraction or kitchen fractions ones. You don't need a complicated numeral to make an interesting math problem. A numerator. Questions about this one? It was mostly to wake up your brain. It's not like you have to be terribly happy with it, but I don't want to leave you needlessly unsatisfied either. Okay, thumbs up, down. Should we move on?
I'm good with it.
Okay, moving on. Something easier. Imagine you have 6 watered up pieces of paper, or actually take 6 things and try making baskets. Throw them in a trash can or throw them somewhere else and record your results. So somebody grab something and throw it and tell us if you hit your target or not. No, okay, so I have a check mark ready, but I'm not going to put it in that box because April missed. Okay, April, try again. No, okay, so again, it's next to the thing. I'm not putting a check mark. Okay, so this one goes inside and we get a check mark there. 4th one. 3 more times. Okay, that one goes in. I need to duplicate my check mark. Okay, so overall, we would write 3 go in out of 6 total. We could say 3 over 6 or 3 out of 6. They are both perfectly good ways in English to describe this. The top is how many things we cared about, how many things worked for us, the 3, and the bottom is how many total there were. Everyone happy with that one?
Yes.
So when we're building fractions, we have to measure 2 things. What's the total number of things we're looking at? And then which ones are in some way extra special? We're counting them in particular. Here's another word problem. Alana and Andy are twins. At their joint birthday party, there's a small chocolate cake for Alana and a small strawberry cake for Andy. And both cakes are the same size. So do you agree that the circles are the same before any lines are drawn to cut them?
Yeah.
So Alana's cake is sliced into 8 pieces. And after party, 3 of these were left over. Andy's cake, he got bigger pieces because they didn't want ice cream, so they got more cake. And after the party, 2 of those were left over. Which cake had the most left over? So do some shading and convince me which cake had the most left over.
I would say his had more left over.
Yeah, it's pretty obvious, right? He has the whole half a cake. And hers isn't half, right? It would be half, except it's missing this piece. So this is a great technique. There's all sorts of things that might happen on a test like the GED, and you're not quite sure what to do. It's normally not too bad once they teach you in Math C how to use fractions on your calculator. But still, sometimes all you have to do is draw a picture and you can say, oh yeah, this one is bigger than that one because this little half part isn't filled in. Okay, I'm going to erase that because I'm not sure what it's doing. I don't want to confuse people later. As a last note, we can use division to make something that looks like a fraction, but it's not describing parts on top that we care about compared to the whole or the total on the bottom. And we see this all the time. If I write 60 miles per hour, it could look like a fraction, but it's not like 60 miles are part of an hour. It's not like I had an hour and somehow I chopped it up and part of it is 60 miles. They're totally different things, right? Distance and time. When we do this kind of thing, when we write a comparison of 2 things like a fraction, we call it a rate. And the reason we do that is we have some tools that we'll learn soon about how to do math with fractions, how to add them and multiply them and stuff. And we might want to do that with the rates. But just realize that rates are not really fractions. They're not parts out of a whole, because sometimes that can trip you up later. Okay, ready to move on? I will stop the recording
Yes.
and move on to the next ToDoodle.